Let's go back to linear algebra and look at a method for solving a system of equations. It's a method I don't usually use, but it can come in handy for certain systems of differential equations. It's called Cramer's rule. Let's let A be an invertible n by n matrix, and let's let B be an n by 1 vector. And then with these sizes, we can see that the system AX equals B has a unique solution, X equals A inverse B. Now, Cramer's rule provides a formula for the components of this vector. In terms of determinants. So specifically, let's let capital BK be the matrix we get from A by inserting B in the kth column. So the matrix obtained by inserting B into the kth column of A. So then this vector, A inverse B, has components given by the kth one is the determinant of this matrix BK that we got from A by putting B into the kth column all over determinant of A. So that's one way of obtaining the solution without doing any row operations. It's not always easier than doing row operations, but it's one method of writing down what the solution is. I'm going to omit the proof and just do an example. You can look up Cramer's rule in the book if you want to see a proof. But for now, let's just do an example. So let's solve the system AX equals B if A equals the matrix -1, 1, 1, 0, 3, 4, 2, 0, 2, and B is the vector -4, -5, 2. So we need to take the determinant of A because that's going to go in the denominator of all our components of the solution. And then we need to put this vector B in for each of the columns one at a time and take the determinant of the matrix that we get each one of those times. So we have determinant A equals negative 6 plus 8 plus 0 minus 6 minus 0 minus 0. So just that. So 8 minus 12 is negative 4. Then we define B1 by putting B in the first column of A instead of negative 1, 0, 2. Negative 4, negative 5, 2, 1, 3, 0, 1, 4, 2. So then x1, the first component of our solution, is determinant of B1 over determinant of A, which is negative 4 times 6 is negative 24, plus 8, plus 0, minus 6, minus 0, minus negative 10, plus 10. So we've got 24 minus 6 is negative 30, plus 10 is negative 20, plus 8 is negative 12. Negative 12 over negative 4, we get 3. X2 is determinant of, we have to write down what B2 is. B2 is, we'll take the first column as it is, then we'll put B in for the second column, negative 4 and negative 5, 2, and take the third column exactly as it is, 1, 4, 2. So x2 is determinant of B2 over negative 4, which is 5 times 2 is 10, minus, let's see, 16 times 2, minus 32, plus 0, plus 10, plus 8, plus 0. So 28 minus 32 over negative 4. And 28 minus 32 is negative 4, isn't it? So negative 4 over negative 4, which is 1. And then B3 is the matrix we get by replacing the third column with B. So negative 1, 0, 2 in the first column, 1, 3, 0 in the second column, and negative 4, negative 5, 2 in the third column. X3 is the determinant of that over a negative 4, which is negative 6 minus 10 plus 0 minus negative 24 plus 24 minus 0 minus 0. So 24 minus 16 is 8. 8 over negative 4 is negative 2. Alright, so now let's use the solution 3, 1, negative 2 and verify that it is actually a solution of the equation. So negative 1, 1, 1, 0, 3, 4, 2, 0, 2 times 3, 1, negative 2 equals negative 3 plus 1 is negative 2, minus 2 is negative 4. 3 minus 8 is negative 5. 6 minus 4 is 2, which is exactly what the right-hand side is supposed to be. So there we have it. The end.